Let us now understand the operation of two quadrant chopper. Two quadrant chopper, we can see that it is a class C chopper. Earlier we have seen the classification of choppers. Down at the bottom you can see there is a characteristics here. It shows two quadrant operation. This is the first quadrant where voltage, output voltage and current both are positive, and second quadrant where output voltage is positive but current is negative, that is current reverses. So this kind of operation can be helpful in case of forward motoring in first quadrant and then reversal of current, so forward braking for the electric vehicle. So let us check the circuit diagram as well as the waveform. In the circuit diagram there are several devices, that is chopper 1 switch 1, okay, chopper 2 switch 2, right, then diode 1 and diode 2, right, and apart from that the waveforms, they indicate the switching sequence. Ig1 shows the switching sequence of chopper 1, so chopper 1 will remain on here, will be off here. Similarly for chopper 2 this is the switching sequence, and then I0 is the output current flowing through the motor, and E0 is the voltage appearing across the motor. Okay, so this load basically means the motor that we want to drive. The first quadrant operation is achieved by CH1 and D1. Chopper CH1 and D1, these two together they achieve the first quadrant operation, while CH2 and D2 they will not have any role to play, so they will not conduct during the first quadrant operation. Okay. Similarly, chopper 2, that is CH2 and D2 will be responsible for the second quadrant operation, and at that time CH1 and D1 will not be conducting. At that time CH1 D1 will not be conducting. Okay. The steady state waveforms, they indicate let us say point P. Here this is point P. At this point chopper CH1 will be triggered and it will start conducting such that the output voltage becomes equal to the supply voltage EDC. So current will flow like this through the inductor, through the motor, and it will be coming back, right. Output voltage is equal to the input voltage and inductor will start storing the energy. So current flowing through the inductor will be maintained like this. Further, let us say at point Q, the CH1 will be turned off. The inductance, the energy stored in the inductance, it will force the load current to flow through diode D1, and this will happen until the voltage across the inductor, that is having this particular polarity, okay, until the voltage across the inductor becomes equal to the back EMF induced across the motor. So since the motor is in operation, it has its own back EMF as well, isn't it? So it has its own back EMF. So this motor will have certain back EMF induced across it. So let me write it here. This is the back EMF. Voltage induced in the motor that acts in opposition to the current. So when this back EMF becomes equal to the voltage across the inductor, the value of current will become 0 at point R. Please see on the waveform, here the current becomes 0. At this point, the chopper CH2 will be triggered. At this point, chopper CH2 is triggered, and still the back EMF has some energy. Now since the back EMF is higher as compared to the voltage induced across it, so back EMF will force the current to flow through CH2 and back to the load. Okay, so back EMF induced in the motor will supply current in the reverse direction. So current through the inductor will reverse, and again it will start storing energy for the reverse direction of current flow. And this will continue until some time, right, until CH2 is turned off. So at this point S, CH2 is turned off, right, and once the CH2 is turned off, again CH1 will be turned off. So CH2 is turned off. Okay. Once the CH2 is turned off, what will happen is that the energy in the inductor along with the back EMF, right, this will force the current to flow through diode D1 and back to the source through this particular path. Okay, so the conduction of current will be from the motor through the inductor through diode D2 and back. So this mode of operation is indicated here between S and T until at point T what will happen is that CH1 will be again triggered and the cycle will keep repeating like this. Again it will repeat. Okay, so this switching sequence is followed, right, and we are able to get a complete 2-quadrant operation with the help of this kind of circuit. And output voltage waveform is also indicated here. Output voltage will be available during the conduction of CH1D2 and will not be available during conduction of CH2D1. Let us now understand the operation of a 4-quadrant chopper. So 4-quadrant chopper is also called as a class E type of chopper, right? So please observe right hand side the characteristics of 4-quadrant chopper. It indicates operation of chopper wherein it will work in all the 4 quadrants. So quadrant 1, then quadrant 2, right, then quadrant 3 and then quadrant 4. All 4 quadrants operations are possible with this type of chopper. So this is a kind of a base chopper that will be suited for the electric vehicle application, wherein there will be like forward motoring, forward braking, similarly reverse motoring and reverse braking operation possible. Okay, so let us understand this operation from the circuit diagram. Kindly recollect that we have studied 2-quadrant chopper wherein there were 2 switches, CH1, CH2, right, and a combination of 2 diodes along with the motor and the inductor, isn't it? So this particular part you can observe, this is like a one class C chopper, and similarly on the other side is another class C chopper with 2 switches and 2 diodes combination along with the motor and inductor. So 2 class C choppers connected in such a manner that we get the class E type of chopper giving 4-quadrant operation back to back. Okay, so let us understand how the operation is possible. Now let us see that we would like to operate in this particular range. Observe the characteristics. We want like to operate in first and second quadrant so that voltage remains positive, but current here can be either positive or negative. So this operation is possible by working in a proper setting in which chopper 4 is always turned on and chopper 3 is always turned off. Okay, so when chopper 4 is turned on and chopper 3 always off, a combination of CH1 and CH2 put together, okay, these 2 devices will enable the operation of first and second quadrant, wherein the voltage will always be positive appearing across the motor like this, okay, but current will either flow in positive direction or negative direction as we have studied during the class C chopper operation study, okay, or 2-quadrant chopper. So current is reversible and voltage will have only one polarity across the motor, that is a positive. So that positive polarity, it will appear here indicated plus and minus, isn't it? So this is first and second quadrant, voltage positive and current reversible. So current will be positive when CH1 operates, current will be negative when CH2 operates, and the energy is fed back to the source. Now let us consider the operation for the third and the fourth quadrant. So for third and fourth quadrant, naturally the voltage appearing across the motor will be negative. So we see that voltage is negative, but current can be either negative or positive. So for such an operation, CH2 is continuously turned on and CH1 is continuously turned off. So main condition is that CH2 will be continuously on, CH1 will be continuously off, and in combination with this CH2 will be operating CH3 and CH4 in class C mode. so that the voltage induced across the motor will have this polarity, reversal of voltage. So you can see right terminal positive, left terminal negative, and current flowing through inductor will be bidirectional. It will be either flowing like this, okay, positive, or this is a negative current, okay, or it will be flowing like this according to the mode of operation of CH3 and CH4. So this way a combination of three devices put together will provide us the third and fourth quadrant operation. Okay, so fourth quadrant operation will be able to achieve full control over the operating modes of electric vehicle, whether it is working in forward motoring, forward braking mode, or reverse motoring or reverse braking mode. So if you remember, we were working the voltage here, this first quadrant is basically it was a forward motoring operation, then this second quadrant it was forward braking where the current reverses to give reverse torque, and then this was third quadrant was the reverse motoring, voltage as well as current negative, and then this was reverse braking where the current reverses in the current changes polarity in the reverse motoring mode.